Hey, hello, welcome. We're in Advanced Algebra 2, and we are going to combine long division, well, polynomial long division, and factoring. It's going to be pretty exciting. We have to start off with this thing called the rational root theorem, though, and basically what it says is these are the numbers we should bother trying, and we know that we have a factor winner when we have a number that you stick into the polynomial to make 0. So if you stick a number into a polynomial to make 0, then you can get the factor from that. This is almost identical to how I was telling you to cheat with the quadratic formula, about 1,000 times. And also, only bother trying the numbers, and this second part's strange, but only bother trying the numbers where the numerator is a factor of the constant and the denominator is a factor of the leading coefficient. That last bit, you're just going to have to do some examples with me on. Probably. Who knows? You are brilliant after all. Anyway, let's do some. Here we go. Now, these will take a while, and there's going to be polynomial division. By now, that shouldn't be terribly exciting, though. So, here we've got this thing, and the leading coefficient is 1. The 1 wasn't written originally, but, you know, it's a 1. And, you know, the factors of 1 are 1, and that's kind of pathetic to even mention, but in contrast, the constant, you know, the number over there with no x hanging around, is 20, and its factors are, well, they're, you know, 1 and 2 and 4 and 5 and 10 and 20. Yeah, so that's a lot of numbers. Now, this means that the only numbers we should bother trying are the numbers where the numerator is from that list of factors of the constant, and the denominator is from the list of factors of the leading coefficient. Now, again, because this is the first example, the leading coefficient was 1, so all the denominators are 1 because there's no factor. So it's 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, and 20 over 1. Almost. However, actually, the truth is, you actually get to do all the pluses and minuses versions of all of them. So the real list is 1 and -1 and 2 and -2 and 4 and -4 and 5 and -5 and 10 and -10 and 20 and -20. Hey, did I mention, yes I did, that it would be really useful to have a graphing calculator for this? Not for the graphing. In fact, frankly folks, almost never for the graphing. Here's what we're going to do. First of all, let's call this polynomial f of x, and I just want to have a name for it for what I'm going to do next. You don't have to really, but I'm going to figure out what f of 1 is. Now, you know, you can take 1 and you can substitute it into all the x's, or you could use the graphing calculator to have it do all this work for you and save you, oh, so much time. Okay, well, it's 44. 44 is a fail number. We're looking for a 0. So 44 was no good. Let's see here, -1. That was 4, also no good. 2 is 112, no good. -2 is 0. Hey, we win. Look at that star, happy face, lucky time. This means, though, and this is important, x plus 2 is a factor. Now, again, if you've worked with me on cheating in prior factoring off the quadratic formula, this should probably make a lot of sense. But x plus 2 is going to be a factor. Okay, since we know that's a factor, we can divide. It's cubic, and we can divide by this linear x plus 2, and, you know, the dividing part is pretty not exciting. You do x squared, you subtract, write down the rest of the stuff, and then you got a 7x to make it work, you subtract the rest of the stuff, and 10x, then you got the 20, and then you do the 10, and then you got the 10x and the 20, and you subtract them, and you get 0. By the way, you will get 0. There will not be a remainder. That's the whole point of it actually working as a factor. So, x plus 2 is a factor, and, big arrow for emphasis, the other part is x squared plus 7x plus 10. I mentioned this in class at the beginning last time, and this is super important because now we're just factoring, well, x plus 2, you know, whatever, that's done. Oh, x plus, that's, let's see, another, well, like x and 5 and x and 2. Boom! So it's actually x plus 2, there's 2 of them, so x plus 2 squared and x plus 5. Huh. That was a long list at the top. Now, the good news, of course, is that this huge list of all this business here, right, this stuff up here, those are things I wrote out this time to try to help you organize what you would try. As you get better, you won't necessarily need to make that full list as long as you are organized in your head. Okay, next example. The leading coefficient is 1. And the constant is 3. Okay, so numbers to try. I mean, 3 doesn't really have a whole lot of factors, right? So it's like 3 plus or minus 1 over 1, plus or minus 3 over 1. I mean, that's it. It's 1, -1, 3, and -3. I mean, those are the only options. So you try those 4 numbers. Again, I'm going to call this f of x just so I can kind of show a list. F of 1 is 3, sad face. F of -1 is, oh gosh, what is it? 13, sad face. F of 3 is 21, sad face. And f of -3 is also 21. Again, a sad face. So this didn't work. We didn't get any zeros. So it doesn't work. No linear factors. Again, the funny story is actually that everything factors, but then you have to involve i's and irrational. It's gross. For what we're doing now, no factors. Okay. Let's do another one. So look at this. It's to the 4th. That's awesome. The leading coefficient is 1. Again, we're talking about that number in front of the x to the 4th. The factors of which are 1. Again, that's kind of silly to write down, but nobody got injured. The constant is 8, and so let's see here. The factors of that are 1 and 2 and 4 and 8. And so our possibilities, numbers to try, I guess I was using in the prior examples. We're talking about plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. Okay, so that's a list of actual 1, 2, 3, 4, plus or minus 8 numbers to try. 1, -1, 2, -2, 4, -4, 8, -8. Again, if you're organized, you don't necessarily need to do all of this listing out, but if you're confused, then it's a good idea to start there. Hey, we're going to call it f of x. You don't have to, but I do just to have something. The book, by the way, calls them capital P of x for polynomial. It's just as good as anything else. Oh my gosh, 1 worked. Just off the bat like that, you're lucky. Okay, I'm going to try some more. By the way, the part where I'm trying more isn't necessarily something you would do, but it's x to the 4th, and so I'd like to get 4 of them. Let's see here. Oh my gosh, 2 worked. Okay. Huh, well, let's see here. -2, nope. And let's see here. 4, nope. And -4, nope. So sad. There we go. There's our frowny face. 8, nope. And -8 is, nope. Okay, so it's x to the 4th. And, what would be super awesome is if we had 4 of them, because then we'd have them. But we only have 2. So in this case, we got some work to do here. Since 1 is a success story, that means x minus 1 is a factor. And similarly, since 2 is a success story, that means x minus 2 is a factor. So let's divide. And when I say let's divide, we're going to divide by x minus 1. So take this original thing and divide by x minus 1. It's not really that exciting, hopefully, by now, right? You do the x cubed, and you subtract, and you subtract, negative 6x cubed, plus then you bring down the other stuff that got left behind. And then, okay, maybe a negative 6x squared, and then subtract it away. Okay. And then you have the 12x to make the 12x squared. Oh, gosh. And hey, 0. Remember I said before, and it was true then and still true now, you have to be getting 0 at the end. If you're not getting 0 at the end, you've flubbed up something along the way, so stop immediately and go back now. Okay, so 0 worked, which meant that it factored. So it's x minus 1 times x cubed minus 6x squared plus 12x minus 8. And you might say, that's delightful, but that doesn't look done, and it's not. But I know x minus 2 is a factor, so I'll take the x cubed part, the answer, the quotient from the first division, and divide it by the x minus 2. You don't want to do the original one by x minus 2. You'll actually end up with a different x cubed, and then you'll be all conflustrated. Do the answer, the quotient, by your other thing to work off of. And that's great, because first of all, it's faster than doing the whole thing, and also you're getting more information. So here we are, and we got an x squared set up, and then we, who knows what's negative 4x, and then it works out, and then what do we got, plus 4, 0, again, like I was saying, it's always going to be 0 because it was a factor, and it worked out well. Okay, what this means is we got x minus 1, that's from before, and now x minus 2, that's new, and x squared minus 4x plus 4, that's our new quotient, right? So just to be clear here, we had this x cubed thing, and we divided it, and it made those two, the x minus 2 factor and the x squared minus 4x plus 4. So, well, that's quadratic. I mean, we can factor that, and it's not a very interesting quadratic, frankly. It's x minus 2 times x minus 2. Oh, I see why I didn't have 4 of them, because I had one of them 3 times. X minus 2 popped up 3 times. A petulant little x minus 2. Anyway, there we have ourselves the factored version. Okay, this one's a little harder. You had a list, you had some numbers, you did some division, and then you kind of had to keep going with the division and do some more division off of your answer from the first division. Yeah, awesome. Okay, next one. Now, this one is different for a different reason, and here the leading coefficient isn't 1. Now it's 18. All the other ones started with a plain like x cubed or x to the 4th, which meant 1. So the factors of 18 are, 1 and 2 and 3 and 6 and 9 and 18. Okay, now here, because I'm not quite as evil, well, I am, but I'm trying not to be, the constant was just 1, so the factors are 1. Okay, so the possibilities are 1 over 1, 1 over 2, 1 over 3, 1 over 6, 1 over 9, 1 over 18. If you sort of know how to use a graphing calculator, you may not know how to enter fractions into the place to get the answers out. So this is definitely something to get help on if you kind of have a general gist of why graphing calculators are awesome now, and if you have one, but you don't know how to make the fractions work, you definitely want to get help, because again, this is all about saving you time. It doesn't make you any smarter. Anybody can do it with a calculator, even Ingrid's silly calculator works. But so f of 1 is 24, no good. F of negative 1 is negative 8, no good. Let's see, f of a half. This is kind of tedious to do, entering into the terrible calculators. Although it still works. Yeah, 2.5. That's no good. Negative a half. Let's get 0. Hey, look at me. Okay, so that means 2x minus 1. I'm sorry. So sorry. 2x plus 1 is a factor. Okay, now, at this point, you actually have 2 choices on how to proceed. You could totally divide by 2x plus 1. And it would take your cubic, because it's 18x to the 3rd. It would reduce it by 1 power, it would make it quadratic, and then you could either factor it with your brain or fake factor it with the quadratic formula. That's not what I'm going to do now, because if you're lucky, you can save yourself even more time. But it's a style thing. It's a choice. Hey, 1/3 works, and that means 3x minus 1 is a factor. Oh. Well, that's pretty awesome. And negative 1/3. Oh, that works too. That means 3x plus 1 is a factor. This gives great contrast with the 3x minus 1 for positive 1/3. like I planned this. Anyway, so that means we're actually done. We don't have to do the long division because there's x to the third originally, and so I need 3 factors. And I have boom, 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 3 factors. Kind of lucky here, but it works fast. Versus, if we go back a couple examples, let's say this one, you only found 2 factors, even though you were hopefully looking for 4. So you kind of luck with that one, you know. And let's see here, this one was just a massive fail, but this one, I didn't mention it at the time, but you know, there'd be 3 factors. We found 1, I guess, and just kind of saw what happened. If we'd gone through the whole list, we've only would have found 2. And that would have been annoying. So the thing about just like keep going, if you're lucky, it totally works out. You can totally bypass all the polynomial division. But if you're not lucky, then you've just kind of wasted some time. Oh well, it's life. Hey, so we will do these problems that are similar to these examples. There will be something else I will be showing you in class as well. It would be awesome if you could start, 1, 2, or 3 of them. I wouldn't necessarily encourage doing all of them, but, I guess it wouldn't hurt my feelings. Anyway, thank you for watching, and as always, let me know if you have any questions.